Thank you very much, Dick. I'm looking forward to presenting on DevOps, and I want to tell you what we're going to cover. We're going to talk first about the state of software, and I'm going to try and convince you that the investment that you would make in DevOps is well worth it. It is not a trivial investment. It's not something that you simply flip a switch or just put in some tools and you've got it. It requires a real investment, both in terms of time and capital, but also in terms of your mindset and how you think about delivering and operating software either within your company or on behalf of your customers. So I want to try and make that case that DevOps is well worth the investment that you would have to make in it. The second piece I'm going to talk about are the steps that it takes to get to DevOps, and this is really at a high level, but it'll give you an idea of the areas you need to address if you decide to make this investment and reap the benefits of DevOps. And finally, because we're an Atlassian shop, I'm going to show you how DevOps is actually supported by some of the Atlassian tools. But as you'll see when we get to that point, it does not require Atlassian tools in any place within the DevOps cycle. It's simply that in order to give you a real sense or a use case for how DevOps works, we're going to use the Atlassian tools to illustrate that. So that's basically the agenda I'm going to go through. So let's start with the state of software as it exists today. As you can see in this slide, everything we do today is software first. Every industry, whether it's P&G, which lives and dies by its software to both market and deliver its products. You can look at Chevrolet or any automotive company today, and if you look at cars that are coming off the lines today and what's being planned, they're really nothing more than rolling computers. The mechanical aspects are well known for the most part, but what's really driving the auto industry today is all about software, whether it's talking about self-driving cars or more modest things that are coming out. It's all about the software. My favorite example in this is the Starbucks example. You would think the Starbucks, where's the software in that? In fact, what Starbucks has done is to roll out all of their equipment such that it can take over-the-air updates. So when they bring out in October that pumpkin latte for the Thanksgiving season, for that fall, they actually send an over-the-air update to all of the machinery in the Starbucks store, which automatically updates, and so that the barista doesn't have to go through training, doesn't have to learn how to assemble a new product. It simply is there as part of the machinery that's in the actual in the Starbucks store. So they're delivering all of this, and they're living by their software. Another example, and again, happens to be one of my favorites because it's around here, is if you go into Panera these days, you could do everything from ordering to sitting down at the table and having your food delivered to you or picking it up. It's all software driven. Yes, they're still selling you food, but it's all about the customer experience, and the customer experience is driven by software. So the point of this is really to enforce that no matter what industry you're in, software is really the driving force that's going to let you stay competitive or beat your competitors and deliver value to your customers, whether they're internal or external. So having said that, most of you are aware that the way in which we build and deliver software has changed substantially over the last 15 years or so. And what you're looking at here is simply a picture of a modern approach. Now, you'll notice it's all stickies on a board, and this is really sort of defines or is a way of showing Agile. And Agile is has really transformed how we do software delivery. I came up in the telecommunications industry. In the telecommunications industry, first AT&T Bell Labs, and then when the divestiture Bellcore really defined how you deliver software. And software at that time was delivered in what we call waterfall methodology. You would do your requirements, and then you would develop, you would test it, you would deliver it to the customer, again, internal or external. And typically our answer when somebody came to us and said, can you deliver some new feature? It was yes, but it'll take you 9 months and $1 million. It didn't really matter what it was because we knew the answer was 9 months and $1 million. And that's because the waterfall approach bundled all of your requirements up at the beginning, then you did all of your development, finally you did all of your testing, and then you delivered the software. And typically that was on a 6-month to 9-month release schedule. But Agile has blown that apart. And Agile has said, now what we try and do is deliver fast, get fast feedback from our users, and then feed that into a very tight cycle. We're going to talk about that in more detail because that's really underlying the DevOps idea as well. When Atlassian went out and did some surveys of customers around the world, they interviewed some 17,000 software professionals. 1,300 of them were Atlassian customers, so they have a big data set to draw from. What they found was that 77% report using some form of Agile, whether it is some kind of, some pure Agile like Scrum or Kanban, or whether it's a combination of those two, whether it's Lean or XP. There are lots of different methodologies that people can report out on and call Agile, and they all have some value. But what you see is that overall, 77% of software organizations are now reporting that they do some form of Agile development. So this is really key, and we're going to build on top of this when we talk about DevOps. The second key factor in supporting DevOps and supporting new ways of rolling out software is Git, and more broadly, what we call a distributed version control system. What this really means is we've changed the paradigm of how we manage the software base, the code base, from being a centralized system that had to be updated in that central server by all of the developers to a decentralized system that allows each developer, each tester, each operations organization to basically have their own sandbox in which they can do experimentation, they can do development, they can do testing with the knowledge that nothing they do can affect the main code branch until and unless they're ready to. So that means that if I am a developer and I have to work on a new feature, I know that I can work on that feature in my environment and do that and save it as often as I need to, test it as often as I need to, and that will never affect the main branch of code until all of the people who have responsibility for it have agreed to take it into that main branch. So Git is, or distributed version control, is really very key to making this whole thing work. And as you can see, 78% of organizations report using some Git or one of its types. Now that gets you to Agile. That gets you the basic idea of being able to develop quickly and deliver functionality as fast as possible. And that takes care of that left-hand side, the development organization. But what we find is even in organizations that are highly agile, there is still these silos between development and operations, between operations and customer service. And what you find is that each has their own priorities, each has their own mandates and their metrics to hit, and sometimes they are working across purposes. And so when the developers hand off code to the operations team and it doesn't work for some reason, or because operations hasn't deployed enough hardware, hasn't upsized the network, perhaps hasn't deployed the new patches on the operating system, now there's finger pointing that goes back and forth between them. Operations and development are not on the same page. And then it gets out to the customer, and the customer service folks are now taking calls from their customers and complaining about the software, and they're pointing back. And so what we find is that even in highly agile organizations, there's still a lot of these silos, these organizations working across purposes. And sort of a health check, oops, I lost my picture, there we go. Sort of the health check that you want to do to say, are these problems affecting me, is that you can look and say, do you have SLAs? the first one says, do your incident response times exceed your SLAs? But I have, as I've been going out and talking to organizations, finding that a lot of organizations don't even have SLAs, or if they have SLAs, they're very broad because even measuring this can be very difficult. And once you do measure it, being able to fix it can be a real problem. If you don't have visibility, if you don't have transparency, you don't know whether you're actually meeting the goals and the targets that you as an organization have either set for yourselves or that you've set for your customers. Is the infrastructure always on fire? Are your operations folks constantly having to deal with problems? They're being reactive instead of proactive in terms of being able to address the problems that are being created by these new deployments. So this is this can be a real issue for your operations team. And as we said before, is there friction between those teams? And I would add customer services into this. And then finally, are your releases slipping? Do your customers trust that when you say, I will be able to have feature X ready for you at the end of the month, that you will in fact have it at the end of the month? Or are you constantly having to explain why you're going to miss that release date because something unexpected happened, something came up, some unplanned work had to be addressed, and therefore you're not able to meet your commitments in terms of time frame? So these are all things you can ask yourselves as to whether or not they, one or more of them, describes your organization. So as I said, highly agile organizations are still finding that they've got these issues that they need to address that go beyond simply how do we deliver software quickly and successfully to how do we operate it and how do we support it and how does the operations and support requirements feed back into development? How do we make sure that we as an organization from end to end are continuously improving and not simply leaving out 2/3 of the develop, operate, and support equation? So the answer that we believe is in DevOps. It is in a culture in which development and operations and support collaborate together, are working together in order to, for the entire application lifecycle, deliver and support this in a way that improves, significantly can improve the customer satisfaction and your competitive position within your own market, whatever that may happen to be. So now that I've talked through what is sort of the motivator for DevOps, let me give you some definition of what DevOps means. DevOps comes from three principles that you see here: workflow, amplify feedback, and continuous experimentation. And it really gets popularized by one of the books that Dick's giving away, The Phoenix Project, which is written by Gene Kim and some of his co-authors. But the Phoenix Project starts and it's built upon a book called The Goal by Eliyahu Goldratt in 1984, in which he's looking at physical manufacturing processes. And the question is, how do you flow physical manufacturing from raw goods to finished product as quickly, as efficiently, and with as high quality as possible? And we identify, and Kimball talks about this in the Phoenix Project, these three ideas, what he calls the three ways. And the first way is workflow, what we call left to right thinking or left to right systems. As you can see in development, the need to do requirements, development, test, operate, and support are the same as they've always been. And this reflects that waterfall thinking that many of us have lived through. And that goes from the left, from the requirements, to the right, to finally supporting this software as it's in deployment and being used by the customer. And our question is, how do we move it from left to right as quickly and efficiently as possible? And what Kim says, and this is again built on Goldratt's theories of constraints, is that we want to focus on those areas that are creating roadblocks, that are our bottlenecks in the software development and support areas. And what we find is that between development and test and operate are some of the biggest bottlenecks that you can address. Sometimes requirements to development can be a huge problem as well, but if you're doing Agile, you find that moving from requirements to development has been an area that you've already addressed, that you're starting to resolve those bottlenecks because you have very tight requirement development loops. But going from development to test still can be a very time-consuming exercise, and going from test to operate can be a very time-consuming exercise. And therefore, what we want to do is attack those two areas in order to remove the inefficiencies that are creeping in and creating those bottlenecks. So that's our left-right workflow. The second way is right to left. We want information that we get from the right-hand box to flow backwards as quickly, as clearly, and as completely as possible. So when testers find a problem, we want that to get back into development fast and as quickly as possible. We don't want to have to wait until testers have completed all of their UAT or all of their integration testing to then start fixing problems. We want to fix those problems quickly. In fact, what we'd like to do is have developers discover those problems before they get into formal tests. So the faster we can move information from right to left, the better. This will tighten up our feedback loop. So that's the second way, which is right to left thinking. And finally, we have this third way, which gets at the cycle of continuous experimentation and continuous improvement. We want to make sure that at every step along the way, we are asking, how can we do this better? How can we make this whole system function more efficiently, with greater quality? And again, if you're doing Agile, this is not something that's new to you because you're probably doing retrospectives that are continuously feeding back into your development team. How can they work better? How can they work faster? How can they avoid problems? Now we want to roll out that thinking across the organization from not just development, but everybody who touches or supports our products. At Amazon, they have bought into DevOps in the biggest way. And this is, I think, one of the best ways of summing it up. If you build it, you now being the team, your team of developers, you build it, you run it. You make sure that whatever you build actually runs. You don't throw software over the fence to it or to an operations organization and say, now it's your responsibility, and saying to the support people, you figure out how to support it. If you're the team that builds it, you're the team that runs it, you're the team that supports it. And to do this, Amazon has bought into a highly decentralized, containerized approach to software deployment in which they're using containers that were the lifetime of which typically is as short as a week, and sometimes can be as short as hours. So they'll bring up a new service in a container. That container will run for typically a week, at which point it will be replaced by a new container that contains new code, which is either fixed or a problem or added some new functionality. So this allows Amazon to deploy literally thousands of times per day into their production environments. So let's talk about what you could think about achieving. The big number on the right, 200 times more frequent deployments. What this means is that you can actually deliver potential code that could be used by your customer 200 times more frequently than you currently do if you're not using the DevOps approach. And when we talk about more frequent deployments, we are not saying that it is required that you deploy that often, that you churn your customer's environment that often. It is simply that you want to have more frequent potential deployments. You want to be able to say, I've got several different features, they're ready to go, and whenever it's appropriate for the customer to roll it into their environment, they can do it. And we know that it's been tested and that it can be rolled out with very little risk. And that's what the numbers on the left-hand side are showing you. The first one, 22% less time on unplanned work, means that you're going to have 22% less time spent doing things you hadn't actually planned to do when you started out the work on that particular release. That you are much more likely to spend focused time doing those things you've identified to be important to your customers, and much less time doing things that you hadn't actually planned on having to do. The 3 times lower change failure rate says that you are 1/3 as likely to cause a problem when you actually deploy your new software than you were before. If you can imagine how much that will affect the confidence of your customer, that when they actually deploy this new software in production, that they are so much less likely to find that they have to roll it back out, because you've created a confidence that it works, and it works when you deliver it. If there is a problem, and there always are, you are 24 times faster to recover from it. That means that a problem that used to take you a day to fix takes you an hour. A problem that used to take you a month to figure out, to do the root cause analysis and go and figure out how to patch it, now might take you a day or 2 days to do. This, again, creates confidence for your customer, and it reduces your support costs, because every day that you're out of operation is costing you money and creating a strain on your support organization. And that last number, 2,500 times shorter lead times, what this means is that if I go back to what I had said earlier about 9 months, $1 million for any feature, now somebody comes to you and says, I need a new feature. You can think about that instead of saying, well, I'll deliver it in the next release 9 months from now. If you've set up your software and architected correctly using DevOps principles, you could potentially say to that person, no problem, I can have that deployed in an hour. And know that that deployment will have much higher quality, much lower risk than it ever had before. So those are some of the things that you can get through a DevOps approach. And these are not pie in the sky. These are actual numbers that have been measured by Atlassian and by Puppet, which did the State of DevOps report. You can go online and you can see Puppet's report on this, and showing some of the improvements that companies have gotten through DevOps. So I encourage you to take a look at that if you want to. So what could you do if you had 10% more engineering time because you don't have all of these unplanned work that you have to do? Well, you could experiment more with how to deliver better software with fewer bugs. You could start thinking about re-architecting your software so that it is even faster, even higher quality. And you can invest in that future quality through automating and increased automation. And we're going to talk about this more because that's really a key factor in the DevOps is automation. And of course, the bottom line to DevOps is you will get a competitive edge. And I can pretty much guarantee, whether you're an internal facing organization or you are actually delivering software to customers, if you are not keeping up, somebody else will find a way to outpace and outdeliver you. So it is critical that you are continuously trying to figure out, how can I deliver faster, better, and cheaper? And we believe that DevOps is really the answer to those questions. So having gone through this, I'm going to talk about 3 areas that are critical for you if you choose to make the investment in DevOps. Culture, practices, and tools. So let's start with culture, and this is really critical. If I were to say one thing you should take out of this talk, it is that tools and practices are not the key. The key to success in DevOps is culture, and it's building this culture of collaboration, which is the essential starting point. And if you don't start here, then everything else you put into place will not yield the results you're trying to get to. The first thing, and perhaps the most important part of your culture, is this idea of shared responsibility. It's something that grows out of the agile mindset, but it's something that needs to spread throughout the entire organization. Everybody, whether you're a developer, a tester, an operations or a system admin or a support desk person, or you're a manager of one of those groups, we are all in this together. We share in the win. We share in the failures. It is not a matter of pointing fingers and blaming. It is a matter of stepping up and saying, how can we as a team have done this better? And what can we do differently next time? And what do we learn? We need to create, in a DevOps environment, a safe space where everybody shares the responsibility together and understands that the failure on one person's part is a failure on all of our parts. It is a way of taking ownership across the entire organization. The second thing we need to do is encourage transparency in our information. Nobody knows what they need to know until it's in front of them. And you don't know what I have to know as the project manager, and I don't necessarily know what you have to know as the developer or the tester. So in other words, what we want to do is make this information entirely transparent across our organization so that everybody can easily get at the information they need quickly, accurately, and completely. We want to have effective communication. We want to make sure that we are talking to each other. And this is one of the reasons I happened to see a Bloomberg article the other day that said that remote working is the pendulum starting to swing back as companies are bringing their workers back into the offices because they want to encourage that informal social sharing that happens when people see each other face to face. And we want to have effective communication. And there are ways to do that don't require co-location and can still support distributed groups or remote workers. But we need to make sure that we are encouraging regular, complete, fast communication with each other. And then finally, at the top right, cross-pollination of teams is a great idea. One of the things that many DevOps teams do now is they rotate people through different roles or tasks within an organization. So a developer may spend a month being a tester. And often, in a number of organizations, developers are required to go out onto the support desk when their feature or their release is delivered. Because by sitting on the support desk, they gain an appreciation for the kinds of problems the customer is seeing. Likewise, operations folks need to learn how to be testers. Operations folks should at least have some idea of what it means to be a developer. And so they rotate people across different organizations, across different desks, if not so that everybody can do everything, but so that everybody gets a sense of what it takes to do somebody else's job. And this gets to the idea that if you walk a mile in somebody else's shoes, you will really understand when they come to you and express a problem and uncover an opportunity for improvement. If you've been in their shoes, you'll understand what it is they're asking you to do. So collaboration and a cultural approach end-to-end in your organization is really the key for successful DevOps. And we're going to talk about practices and tools. If you get the culture right, the rest will follow. If you don't get the culture right, the practices and tools are nice to have, and you will get a small improvement, but they won't get you to a real DevOps win. Let's talk about practices. We talked about Agile. Many of you are already doing Agile. Most companies are in some form or fashion doing some form of Agile, so we won't go into that in detail. Distributed version control I talked about, that's Git. And that's the idea, again, that when a developer, and I'll show this to you in our use case, when a developer is going to introduce some new software, whether it's a new feature or a patch or a bug fix, they are going to create an environment and a sandbox in which they can do their work, build their software, test their software, and it never touches the main branch. In fact, what we are seeing now, again, in organizations that are adopting DevOps in a big way, is that not only is the software, the code itself going into version control, but all of the configuration parameters are now becoming version controlled. So not only are you version controlling the code, but you're also the configuration parameters for your operating system, the database, at least your test data is going into under version control, the schema that describes your data, your database goes into version control, network configuration goes into version control. Every piece of it goes into version control, and so you can then pull an entire environment right out of your version control system and know exactly how it's configured. The last piece is continuous integration, and this is really key, and this is where most organizations are going to struggle. Once they've done the cultural, they're now going to have to make an investment in continuous integration, and that means two pieces. That's the development to test, if we remember that bottleneck we talked about. How do I quickly test new code? Ideally, the way we want to work is a developer pulls a new branch, that's the version control system, and the first thing that happens when they pull that branch is automatically it builds the software. So now they've got confirmation that the branch that they pulled can successfully build. And then it runs all the tests. So now we know not only did it successfully build the software, but all the tests succeeded. Now I can go in as a developer and start making code changes. And every time I commit my change to my local environment, it builds the entire software piece and it runs all the tests. And now as a developer, I will quickly see whether or not something I did broke the software. If it's all green, as we say, then it's ready to be merged back in, and we'll talk a little bit about what that means from a process standpoint. But the key to successful DevOps practice is automating your tests, automating your builds, and as we'll see, automating your deployment. The ability to basically have a developer say, I've coded it, I've tested it, it's been reviewed, and my release manager or whoever is the decision maker has said it's ready to go. They push a button and it gets deployed into, or it gets packaged if you're shipping software to a customer, it gets packaged, and that's where it becomes potentially deployable. Those are our practices, and those are the key practices for DevOps success. So let's talk about tools. This is your application lifecycle. You've got plan in the upper left, moving around counterclockwise. You plan your software, that's your requirements, you build it. You do your continuous integration, that's building the software, continuously testing the software, having it ready to deploy. Finally, you go and you deploy it, you operate it, and you get this continuous feedback from real-life use of the software, which feeds back into your plan, and the cycle starts again. And around the outside is all this real-time communication that is making sure that we know at every point in this cycle, we know what's going on. We have visibility into the branches, into the builds, into the deployments, into who's operating it, how many bugs have been reported against it, and so on. That's that real-time communication. Now, as I said, we at RightStar are both BMC and an Atlassian shop, and I come from the Atlassian practice. So my focus is going to be on showing you how Atlassian addresses this. And Atlassian does a really nice job because, as you can see, they cover each and every piece of this cycle, and it's all integrated. So if you go and you go out for the Atlassian stack, which gives you access to all the software, you will get pre-integrated all of these capabilities. But it is not necessary and it is not required that you use only Atlassian software. And as you can see, each of the areas can be replaced by other things. You can do planning in a number of different tools. You can be building using NPM or Docker, for instance. Continuous integration, Jenkins is up on the upper left. That's a very popular open source. You can deploy. Puppet is one of the best out there for doing deployment, and so on. So it is not about Atlassian. It's not about specific tools. It's about having tools that give you the ability to work through this cycle. But as I said, we're going to go back and look at the Atlassian tools and how this feeds into DevOps. So this is the last part, and I'm going to take you through a use case of from a bug that's been found in an operating environment to the fix that gets deployed, and how the different tools are used to do that. Teams in Space is Atlassian's demonstration project, and if you purchase Jira software, you can get the Teams in Space as your demo data, and this is what they use to demonstrate their software. So in this particular case, we've got software out there, and some incident occurs. And what happens in this particular instance is that something is raised an alert into HipChat. HipChat is Atlassian's real-time communication tool. It's very similar to Slack, for those of you who have used Slack. It has lots of integrations. Things like PagerDuty, which you'll see in a moment, can integrate into this. And HipChat alerts Sam, who's an operations engineer. And as you can see, it's posted from PagerDuty automatically. It said there's some incident that has been triggered. Now, the incident that we're going to talk about happens to be a problem with the cluster that's running the software. It's getting bogged down. We're finding response times to be lagging. And one of our monitoring tools have picked this up and automatically triggered an incident through PagerDuty into HipChat. So Sam, our engineer, comes into Service Desk. That is the piece of software where incidents are going to be noted. That's your ITSM tool. And Sam is going to come and raise an incident in Service Desk. And so something like this: performance on cluster node 2 is degraded. And here's the information about it. It's priority. It's a blocker. That means it's very high priority. We need to take care of it right away. And I've got all the information that I need in order to start the process of getting this addressed. So now what happens is Sally, developer, is notified through her mobile phone, which is hooked into HipChat, and she finds out that here's a problem. It's a high priority. She needs to immediately get involved and start to take care of this. So now we've got people who are working on it. So we're going to start swarming. What this basically means is that Sally's going to gather her team, her SWAT team, that's going to come in and say, okay, we've got this blocker issue. It's got to be resolved. How do we do this quickly? We're going to first do one thing. We're going to go out to status page, which is an Atlassian acquisition, which runs out on the web. It's got 5 nines reliability, and it's a place where the customers can be notified that we know there's a problem and we are doing something about this problem. And what this will do is it will almost immediately start to reduce the strain on your support team, on your help desk agents, because customers will start to learn the first place they go is to your status page to see, oh, they already know there's a problem, no need for me to call, they're working on it. And one of the nice things that I can do as a customer is I can subscribe to this. And I can say, keep sending me updates so that I know when it's been fixed. And I do this quite honestly. I do this with Atlassian all the time. Subscribe to the problems, and I know then that they've been fixed. Now, in this particular instance, our team has gone in. They've gone into Confluence. Confluence is sort of a wiki on steroids, where this team has created a knowledge base where they've captured resolutions to common problems or problems that they've seen in the past. And what they've determined by looking at Confluence is, if I add a note to my cluster, that will address the problem. And so I can quickly resolve the problem. I would go back to status page, which you don't see here, and indicate that the problem has now been resolved. My customers who subscribed would see the problem's resolved, and they would then be notified. But now what we're going to say is that this is a recurring problem. And the team, Sally and her team, have determined that this is something we're going to fix in our software. It's not simply, we don't want to keep throwing hardware at this problem. We want to fix the problem. It's a caching problem in the software. And so Sally goes in to Jira Software, and she creates a report that says, I'm going to put on the backlog something that says I need to fix this cache issue. Now, this isn't necessarily something that's going to go right in and be fixed immediately, or it might be. It depends on the severity or the importance of this. Somebody, a product manager, a product owner, is making a determination as to where this fits within the prioritization of work that needs to be done. But in this case, we're going to say that it's high enough that it really needs to be done right away. And what happens, just to close out our incident, is we do a retrospective. We use Confluence. Confluence is a nice template for driving retrospectives, asking the question we always ask in our retrospectives: what did we do well? What should we have done better? What are the action items that came out of this? And this is all captured right in Confluence. Okay, so that takes us through the incident. But let's talk about development. So we now have this item, which is in our backlog, to fix the caching issue. So Jennifer, who's one of our developers, goes into the sprint board. She sees that I have this TIS-67, fix the cache issue. She moves it, she assigns it to herself, and she moves it to in progress. What Jennifer does is she then says, I'm going to branch, this is now Bitbucket, which is the Git front end. This is how, this makes it much easier for your developers to use Git and that distributed version control system. She branches off of it, and she has now her own environment in which she starts doing her code, her testing, her builds. This gives her complete visibility, and anybody else who wants to look at it, complete visibility into the changes that Jennifer is making. Bamboo is the continuous deployment, continuous integration tool that's automatically running the tests, the builds, and when we say so, the deployment. This is all happening in Bamboo, and keeping track of it. And one of the real beauties, again, of the Atlassian stack is that Bamboo and Bitbucket are feeding back into Jira to say that we did 2 branches, we had 8 commits, we did 2 pull requests, that's the merge into the main branch, 4 builds, it's a green, that's that check mark. So we're ready to go. This thing has been done. We're ready to deploy it if my release manager says, go ahead and deploy. So my release manager goes into Jira Software, and he can quickly see all of the different issues that he's decided should be part of this release 3.0. He can keep track of everything that's going on. He knows what the status is. He knows whether it's built successfully. He now has a very clear idea as to whether this release is on time or whether things are slipping, and maybe he has to either cut scope or advise the customer of a date, whatever choice he's going to make, but he has complete visibility in one place into what's going on with that release. John says, yep, we're ready to release, clicks the button, it goes to Bamboo, and Bamboo pushes out that software either into production environment if it's internal, or into a package or staging area if it's going to be external to be shipped out to customers. So as we finish, what are the key things that we're seeing? We're seeing that you get more builds, and you're getting like 10 times to 20 times more builds per month. That's a good thing, because every time you build, you're figuring out whether or not something broke, whether or not there's a problem with the software. The more times you build, the better quality you're going to deliver. You're getting faster velocity, because now that I can build and deploy, I can do very, very small changes. I can fix just one small bug. I can deliver just one small new feature. I can make one small change and do it with high confidence that the quality will be there. I can have my development teams and their supporting teams, operations, and testers work with much greater independence, because they know that each code branch that they're receiving is going to be independently tested and built successfully. So as I wrap up, culture, key. I cannot stress enough. It's about thinking differently, and therefore you will work differently. You are going to be much faster about and smarter working through automation. You're going to resolve your problems much, much faster than you ever have before. And you're going to have a much better control on the prioritization of the work that you're delivering to your customers. You're going to deliver faster, better, and cheaper. And that means competitive advantage and higher margins for you as an organization. So I'm going to turn it back over to Dick. That's the whole presentation. And hopefully there's enough time here for folks who want to ask questions.